Alright, so in this second video, what we're going to do is instead of having one predictor variable or one independent variable, we're going to have three. So this is going to be a three-way ANOVA instead of a one-way ANOVA. And before we go into it, I just want to mention that for one-way ANOVA, I went to general linear model and then I went to univariate. But you could also have gone to compare means and then go to one-way ANOVA. But obviously this command only allows for one-way ANOVA, so once you move on to two-way ANOVAs and so on, you can't use this. So my advice is just use the univariate command for all of them. Okay, so if we open this up, we had condition previously, and now we're simply going to add student type and school type to the fixed factors. And this time if you go to plots, what you can do is you can tell it to plot something on the horizontal axis, something as separate lines, and then something else as separate plots. So let's say that we want to have condition on the horizontal axis or the x-axis. We wanted to plot student type as separate lines, so we have a line for undergrads and a line for grad students. And then it's going to plot school type as two different plots. So one plot for public schools and one plot for private schools. And so just make sure to click on add and add the plot in there, and then hit continue. And then, okay. Alright, so now you're getting the between subjects factors here. It's telling you the levels for each of these and how many people you have in each of these conditions. And so this is a slightly larger table right here. One thing to note is make sure you don't confuse the intercepts significance for one of the factors. So the intercept being significant just means that it's different from 0, but that's not something that we're typically interested in. So condition, again, isn't significant. Student type, however, is under 0.05, so this looks like it's significant. So in other words, it seems to make a difference whether you're an undergrad or a grad student. Then if we look at school type, not significant, and then here you would have the interaction between condition and student type, condition and school type, student type and school type, and finally the three-way interaction between all three of them. So none of these are under 0.05, so they're not significant, but obviously if any of these would be under 0.05, then you would say that you had a significant interaction. Again, these are the degrees of freedom error or within, and these right here in the model are the degrees of freedom between. Same for the mean squares right here. Cool. And so the next thing that you notice that you have the R squared right here again. So this model explains 8.7% of the variance. But if you look at the significance level for the whole model, it's 0.298. So this is not significant. In other words, whatever amount of variance this is explaining is not significantly different. And here is the plot. So as we asked SPSS to do, the first plot is for public schools and the second plot is for private schools. So it looks like regardless of public school, it looks like, you know, people who are in the 50 milligram caffeine are doing slightly better in public schools. And then it looks like there's a difference, a pretty significant difference between undergraduates and graduate students in private school, as well as in public schools. Like the grad students are always scoring higher than the undergrads. So that's how you basically check that there's a mean effect of student type, is there's always a pretty significant distance between the red and the blue line.